All right, so section 13.4b is titled All Polar Coordinates of a Point. And so what they want us to do is they want us to look at one given point and then determine the other three, which ends up being a total of 4 points that give the same coordinates, that will end up with the same ending spot, okay? And if you have your unit circle, that's helpful, obviously. So let's look at the first one. It says find all polar coordinates of the given polar coordinates from negative 2 pi to positive 2 pi. What that notation just means between negative 2 pi and positive 2 pi, because there could be multiples of each of those. Okay, so we just want basically one rotation clockwise and one rotation counterclockwise. Okay, so the point that they're giving us on the first one is 2 units. That's the radius, or what we learned yesterday was the distance, and it's at 5 pi over 4. So if you go on your unit circle to 5 pi over 4, you're at 225. It's between the 30 and the 60 right here, so I just drew it in. Your best bet is just to draw it in all the way through your whole units, your whole polar graph, okay? And then graph the first one, which would be 1, 2 units, okay? So it's right there, okay? That's one of 4. I guess you have to be given 1 to get the other 3, okay? All right, so how else can we get this point? You need to have a total of 4. So 1 is going to be given. Your radius, you want 2 that are positive and 2 that are negative of that same number. So you'll notice I have positive 2, negative 2, negative 2. And then you want your angle theta to be 2 of them clockwise and 2 of them counterclockwise. All right. So the first one, the 5 pi over 4 is counterclockwise, right? So what would get us the clockwise to that same spot? So if we went 5 pi over 4 this way, we would go negative 3 pi over 4 this way and 2 units. So these two are right here, okay? To get the other 2 points, we need to get to this side of it, but then we need to say negative 2. So think of it as you want to get here, but instead of saying positive 2, you want the opposite direction. So the counterclockwise would be pi over 4, and the clockwise would be negative 7 pi over 4. Those two would get you to the same spot. Is it like the box that says find all the polar coordinates of a given polar coordinates from negative 360 to positive 360. That's the same as negative 2 pi to 2 pi. And the one that we're given is 3 to 80. Okay? So we go on our little unit circle, and 280 is not on there, right? But we can figure out where 280 should be. Should be a little bit past the 270 and before the 300, right? Everybody see that? So I, again, drew it in, and just go ahead and draw it all the way across, because you're going to need both of those. So for the positive 3 and 3, we've already got the 3 280, so we need the negative that gets us there, right? So we're going to take 280 minus 360. That gets us negative 80. So 280 and negative 80 are the same spot. Right? Yes? Yes. Okay. Then we need to think of it as, okay, we need to get this side, but we need negative 3 and negative 3, right? So that would be how many degrees? We just passed the 90, so it would be 100, right? One way to get it is to say the 280 minus the 180 would get us to 100. And then if you subtract 360 from that, you would get negative 260. And those would be your negative and your negative. We good? Yeah. Any questions on that? Yes. Converting rectangular to polar coordinates. Okay, so this is the opposite of what we did yesterday. Yesterday we went r theta to xy. Now we're going to go xy to r theta. Okay, so the two formulas that you are going to need, they write it as x squared plus y squared equals r squared. I actually prefer simplifying it to r equals the square root of x squared plus y squared, and changing the tangent of theta equals y over x to just simply plugging it into the inverse tan of y over x, because that's what you end up doing anyway. So I kind of just ignore these two and just use these two. All right. So for the box on the left, it says find all the polar coordinates of the rectangular coordinates of negative 2 pi to 2 pi. So if we're given a point at negative 1 rad 3, first we need to convert it. Okay, so we're going to plug it into the r squared equals the negative 1 squared plus the rad 3 squared. Then we end up taking the square root of it. And so we get a radius of 2. That's going to give us the first of our 4 answers that because they're saying to find all of them. So we're going to just get one of them and then do what we did up top to get the other 3. Okay? But we also need the angle. Okay, so we're going to take the inverse tangent of the rad 3, which is our y value, divided by our x value, which is negative 1. And I got negative 60 degrees. So negative 60 degrees is actually right here. But our r was positive. Let me think about that for a second. And that's why I wrote that. We have to look at what quadrant it's in, the original point. So if it's negative 1, rad 3, that's going to put it in quadrant 2 over here. So that's how I knew it had to be 2 and then positive 120. Okay? And the 120 is just across from the negative 60. So that's how I got that. Okay. Like where? Because it would seem like this should be 2, negative 60. But it's actually 2, 120. And then the opposite, the other positive, because we have to have 2 positives, 2 negatives. So 120 is, if you take 120 minus 360, you're going to end up at negative 240. Then I calculated this, which was negative 60, but you want to go to the other direction to put it back in quadrant 2. And then if you add 360 to that, you're going to get 300. All right? I'm expecting, because they're both negative, negative, right? That's going to put it over here in quadrant 3. So you can see that using this second formula is a little less work than using the first formula. So that's why I just kind of said, ignore this one, go straight for that one. And then ignore this one, go straight for that one. So you calculate the radius to be 3.6, which is the first time you've kind of seen it not on a whole number, but it's fine. It's going to be a little more than halfway between 3 and 4. Okay? And then calculate the theta angle. It's roughly 56.3 degrees. So 56.3 degrees is actually over here in quadrant 1. Okay, so it's kind of like this problem on the left, which looked like it should have come out in quadrant 4, but it's really in quadrant 2. So this one looks like it should be in quadrant 1, but it's really in quadrant 3. So we're actually talking about this point, not that point right there. Okay? So this point right here is the one we need to give all 4 answers for. Okay, so the radius or the distance, the r, is 3.6. So you should have 2 positive, 2 negative. And then to calculate this number, I just subtracted 56.3 from 360. Or what did, no, I added 180 to that, sorry. 180 plus 56.3, yeah. So add 180 to this, that gets you to quadrant 3. Okay. Then to get the negative value, subtract that from 360. Okay. Then to get these two, this one is the 56, but go the opposite direction. And then this last one is the negative and go the opposite direction.